Welcome. This is video number 133 and it's lecture number 3. Today's lecture is based on hypothesis testing 1. Uh, Before I discuss hypothesis testing, let me just repeat data and variables. Data are the answers to questions or measurements from the experiment, and variable is the measurement which varies between subjects, for example height or gender. So here in this table you see there are 4 columns A, B, C and D, and column A shows subjects, and B shows gender, and C shows number of years, and column D shows height. So these are variables. So one row is per subject and one variable is per column. So column shows variables and row shows subject. Data type may be scale, measurements, numerical, count data, and similarly we have categorical, which appears as categories. Types of variables: scale, categorical. Now in scale variables we may have continuous variables, we may have discrete variables, and under categorical we may have ordinal and we may have nominal. Under nominal there is no meaningful order, whereas under ordinal there is a obvious order. Now this is just nominal, and this is ordinal. There is ordering or ranking 1, 2, 3, and this is discrete, counts or integers, and this is continuous. You see, under continuous variable the variable covers all possible values within intervals. There are a number of questions. What data types relate to the following questions? What is your favorite subject? And this subject includes maths, English, science, art, French. I leave this to you, and later on I will show you the answer. Then there is gender, male and female. You have to decide what types of data type these are. And question number 3, I consider myself to be good at mathematics. Strongly disagree, not sure, agree, strongly agree. And finally question number 4, show score in a recent mock GAC maths examination, and the score is between 0 and 100%. I hope you have solved these questions. If not, then here are the answers. Now the first question is nominal. There is no ordering. The second question is binary, nominal. There are 2 categories, male, female. The third question answer is ordinal. You see there is ordering. And the fourth one is scale. Population and samples. Taking a sample from a population. Now you see here this is population, and we want to know about this population, and then we make a random selection from this population, and that is sample, and we have these to work with. We have to work with this sample, and then we calculate sample mean, that is statistic. We call this sample mean, and the population mean is mu, which is a parameter. So we make inference on the basis of sample about the population, and sample data represents the whole population. Point estimation. Sample data is used to estimate parameters of a population. Statistics are calculated using sample data, whereas parameters are the characteristics of population data. For example, population mean and population standard deviation are parameters, whereas sample mean and sample standard deviations are statistics, and these are the estimates of the parameters. That is statistics, that is values based on sample, are estimates of the population parameters. How can exam score data be summarized? Now this is the exam score. Exam marks for 60 students marked out of 65. So how can we summarize this? You have to think about this. This is raw data. Now one summary would be mean, and the formula for the mean is summation xi varies from 1 to n. divided by n, and that is equal to x bar. And the second one is the standard deviation. Small s is a measure of how much the individuals differ from the mean. And large standard deviation means that the spread is very much, and small standard deviation means that there is a little spread from the mean. For exam scores, mean is equal to 30.5 and standard deviation is 14.46. Now, interpretation of standard deviation. The larger the standard deviation, the more the spread out. Now, if you see in this diagram, the standard deviation is equal to 100, whereas in this diagram, the standard deviation is equal to 30. So this means that here the spread is more, here the data spread out more, and here the variation is little, small. Scale data. If we have scale data, to analyze it, we often assume it follows a normal distribution, and here is a kind of normal distribution which is a bell-shaped. So for numerical data, we assume that the data follow normality, or it follows normal distribution. How could you explain this to a student, what we mean by data being assumed to follow a normal distribution? This is a question for you to think about, and you have to answer this question. You have how to explain this to your students. What does it mean when we say that the data follow normal distribution? Here is a group of frequency distribution, frequency table. This is a 0 but less than 10. Matlab, this means this range is less than or equal to 10, and then 10 to 20, 20 to 30, and so on. And these are the frequencies, and these are the percentages. So the sum of these percentages is equal to 100, and the sum of these frequencies is equal to 60. Remember, I told you earlier that these are the marks of 60 students, which marked out of 65. Now we can make histogram and probability distribution of the exam marks data. Now this is the histogram, and this is the probability density function, and here you can see that we can smooth out this. This is a type of normal distribution. Let me do like this, or let us suppose this is IQ data, and it is normally distributed. Now the average IQ varies between 85 and 115, because the standard deviation is 15.3 and the mean IQ is 100. So this is the average, this is above the average, and this area is called Mensa. And this is another distribution. This middle is 95% of the data is in the middle, so 95% of the values fall in this area. This is standard minus 1.96 standard deviation and plus 1.96 standard deviation. Here the lowest 2.5% of the data, highest 2.5% of the data, and this is a P score is greater than 130, and here the P score is less than 70. So mean minus 1.96 times standard deviation, so that is equal to 70. So this relates to this place, mean plus 1.96 plus standard deviation, that is equal to 130, and this refers to this area. So 95% of the people have an IQ between 70 and 130. Assessing normality. Charts can be used to informally assess whether the data is normally distributed or not. So we can use this histogram, or we can use this box plot, and if you have data like this, that is normally distributed, and if you have distribution like this, that is skewed. One is right skewed and one is left skewed. So this means the mean and median are very different for the skewed data. but for the normal distribution, mean and median are the same. Discussion: is the following statement: 2 out of 3 people earn less than the average income? A, true, false, B, false, C, don't know. You have to answer this. Sometimes the median makes more sense, and in this chart you can compare. The median income is 427 pounds per week, whereas the mean income is 528 per week. 60% of the median earn 256 pounds per week. 4.12 million individuals with income above 1000 pounds per week are here, and so this is the distribution of the data. So can you guess from this distribution whether this is a normal distribution or not? You can do that with the help of Jarka-Bera test. You can do that with the help of Shapiro-Wilk test, or you can do that with the help of Kolmogorov-Smirnov test. So here are the 2/3 of the people in this area, and 50% lie here in this area. We have to choose summary statistics, which average and measure of spread, scale, categorical. If we have normally distributed data, then we may use mean and standard deviation. If the data is skewed, then we may use median as a measure of central tendency and interquartile range as measure of dispersion. If the data is ordinal, then we may also use median and interquartile as a measure of central tendency and measure of dispersion. For nominal data, we use mode as a measure of central tendency, but we don't use any measure of dispersion for the nominal data. Which graph we may use? For scale, we may use, if there is only one variable, then we use a histogram. We may also use scatter plot. If the variable is categorical, then we may use box plot, confidence interval plot, and so on. And for categorical, we may use a pie chart or bar diagram or bar graph. We may also use box plot, confidence interval plot, and we may also use stacked multiple bar chart for categorical variables. Which graph would you use when investigating whether daily temperature and ice cream sales were related? And question number 2, comparison of mean reaction time for a group having alcohol and a group of drinking water. Think on this and come up with the answer. This is an exercise from a book, Ticket Cost Comparison, and summary statistics for cost of ticket. Cost of Titanic ticket by survival. Average is 23.4, median is 10.5 for those who died, and standard deviation was 34.2. Interquartile range is 18.2, minimum is 0, and maximum is 263. And these are the summary statistics for those who survived. So is there a big difference in average ticket price by group? Which group has data which is more spread out? Is the data skewed? Is the mean or median a better summary measures? Think on these questions and come up with the answers. These are exercises for you. Now again, which graph? This is solution. For scale, we may use histogram when there is only one variable. We may use scatter plot when one is scale and another one is scale. When one is scale and another one is categorical, we may use box plot, confidence interval, or plot. If one variable is categorical, so for one variable we may use pie chart or bar graph. And if one is categorical and another one is scale, then we may use box plot or confidence interval plot. And if the two variables are categorical, then we may use a stacked or multiple bar chart. Which group would you use when investigating this? So as I asked this question earlier, whether daily temperature and ice cream sales were related. For that we may use scatter diagram. So this is here. A comparison of mean reaction time for a group having alcohol and a group drinking water. So we may use this box part or confidence interval part. So we are here, both are categorical. Ticket cost comparison solution. For the second question, is there a big difference in average ticket price by group? The mean and median are much bigger in those who survived. Which group has data which is more spread out? The standard deviation in interquartile range are much bigger for those who survived. So that data is more spread out. So these are the questions. These are the answer for the questions. The answer are given in red. Is the data skewed? Yes. The medians are much smaller than the means, and the plots show the data is positively skewed. Is the mean or median a better summary measure? The median as the data is skewed. So for this one, the answers are these. So you can just read these answers and you can use those answers for these questions. Now I switch over to hypothesis testing. What is hypothesis testing? It is an objective method of making decisions or inferences from sample data, and that is evidence. Sample data gives us evidence. Sample data used to choose between two choices, that is hypothesis or statements about population. So what are those statements about population? Typically we do this by comparing what we have observed to what we expected if one of the statements, that is null hypothesis, was true. So there are two types of hypotheses. One is null hypothesis and another one is alternative hypothesis. So we always have two hypotheses. Alternative hypothesis is also called research hypothesis, or it is alternative hypothesis, and what we aim to gather evidence of typically that there is a difference, effect or relationship, etc. Whereas null hypothesis is shown by H0, and what we assume is true to begin with typically that there is no difference, no effect or no relationship. So null hypothesis basically refers to no, and no means there is no difference between two groups or between two means, or there is no effect, or then there is no relationship between or among variables. Now how would you help a student understand what hypothesis testing is and why they need to use it? As a teacher, you must know the testing of hypothesis, its meaning, its importance, its application, and statistics and research. And I hope you can easily make understand your students what hypothesis testing is and why do we need to use them. You could try to explain things in the context of the court case. Say for example, members of a jury have to decide whether a person is guilty or innocent based on evidence. Now the null hypothesis would be that the person is not guilty. We can alternatively say that the person is innocent. And the alternative or the research hypothesis would be the person is guilty or not innocent. So the null can only be rejected if there is strong evidence to doubt it. For example, the jury can only convict if there is beyond reasonable doubt for the null hypothesis of innocence. They do not know whether the person is really guilty or innocent, so they may make a mistake. Now these mistakes are called types of errors in statistics. Now if you look at this diagram here, H0 is true difference does not exist in population, and study reports no difference. So the conclusion is right. If alternative is true and difference does exist in the population and the study also reports that there is difference, so we reject H naught and our decision is correct. But if H naught is true, that difference does not exist, but the study reports is a difference, that there is a difference. So and we reject H naught. I mean the conclusion is that there is difference, but we still reject H naught. So in that case, we make an error, and that is called type 1 error. Now coming to this, H naught is true, difference does exist, but study reports no difference. So we do not reject H naught. So if we do that, then we are committing type 2 error. So these are basically two types of error that the statisticians or the researcher usually make. So one should be very much careful when we make conclusions or decisions. So typically we stick to a 5% risk, that is level of significance, and probability of this is power of the test controlled by a sample size 1 minus power of test. Steps to undertake a hypothesis test. First of all, you will define a study question, then you will set null and alternative hypotheses, then we compute a test statistic. It may be coefficient of correlation, it may be coefficient of a variable, it may be any test, it may be t-test, it may be z-test, it may be f-test, or it may be any other test. Then we will calculate the p-value or the significance value, and then we will make a decision and interpret our conclusions. So choose a suitable test, that is very much important, and that depends upon your understanding what is your null hypothesis and what is your alternative hypothesis, and then you have to decide which type of test we need to use. This is very much important. Here is an example of Titanic. The ship Titanic sank in 1912 with the loss of most of its passengers, and according to reports, 809 of the 1309 passengers and crew died, and that means that 61.8% died in that sinking of the ship. Now the research question is, did class of travel affect survival? What does it mean? So here we will use a chi-square test because the two variables are categorical. So the null hypothesis would be there is no association between class and interval. Now class and survival, these are two categorical variables, so we are going to use chi-square test. And our alternative hypothesis would be there is an association. So no for null, no goes with null, is goes with existence, that is alternative, and it means that there is an association between class and survival. And here is the class survived cross tabulation from SPSS. So there are three classes, first, second, third, and these are survival, died or survived. So these are the frequencies. Total number of those who died are 809, and those who survived are 500. So the total number of passengers was 1309, and this is the total number of passenger in first class, total number of passengers in second class, and total number of passengers in third class. So we have to decide on the basis of chi-square whether there was any association between class and survival. Now this is 3 by 2 contingency table. This is three rows and 2 columns, so 3 by 2 contingency table. So there are 6 cells or 6 values. What would be expected if the null is true? Same proportion of the people would have died in each class. Overall, 809 people died out of 1309, and that is 61.8%. But a comparison of percentage of death observed and expected, this is the expected deaths in first, second and third class. These are the 60.8% in all the 3 classes. Here we are comparing the observed with the expected. Now in third class the expected deaths are more than 70%. In second the observed deaths are less than 60%, whereas the expected are greater than 60%, that is 61.8%. And the first class the percentage of observed deaths is less than 40%, whereas the expected deaths are 61.8%. So there seems association between class and survival. Here these are the frequency of deaths observed and expected. So again the observed deaths here are much lower. Observed deaths here are greater than class 2, class 1 are the first class, and the expected deaths are less as compared to this, and here is also the observed deaths are much more in third class, and the expected deaths are also greater than these 2 classes. So expected number of dying in each class is 0.618 number in classes. Now the chi-square test is used when we want to see if 2 categorical variables are associated or related. The test statistic for chi-square test uses the sum of the square differences between each pair of observed and expected values, and here is the formula: chi-square is equal to summation I varies from 1 to n OI minus EI squared divided by EI, where OI is the ith observed value and EI is the ith expected value. And if you use SPSS for chi-square statistics, we'll go to analyze, then descriptive statistic, and then we will click on cross steps, and after that we will click on statistics button and select the chi-squared, and we will get this output. And here the Pearson chi-square value is 127.859. this is degrees of freedom. This is asymptotic two-sided significance. This is log likelihood ratio. This is linear by linear association, and these are the number of valid cases. Now this superscript says 0 cells or 0.0% have expected count less than 5. So the minimum expected count is 105.81. So the test statistic, that is the chi-squared value, is 127.859, and the p-value is less than 0.001. So double clicking on the output will display the p-value to more decimal places. Now hypothesis testing and decision rule. We can use statistical software to undertake hypothesis tests. Say for example SPSS. One part of the output is a p-value. If p is less than 0.05, we will reject null hypothesis, and there is enough evidence of HA being true, that is alternative hypothesis of being true, and we would conclude that there is association between the 2 categorical variables, that is class and survival. So if p-value is greater than 0.05, so we will not reject H0, and we will conclude that there is no association between class and survival. Chi-square distribution. The p-value is calculating using chi-square distribution for this test. Chi-squared is a skew distribution which varies depending on the degrees of freedom. If degrees of freedom are equal to 2, now this distribution will be like this. If the degrees of freedom are 3, then it will be like this. And if the degree of freedoms are 4, then it will be like this. Now testing relationship between two v degrees of freedom, number of rows minus 1 times number of columns minus 1, and note one sample test, v is the degrees of freedom, outcomes minus 1. What is a p-value? The technical answer: it's the probability of getting a test statistic at least as extreme as the one calculated if the null is true. In Titanic example, the probability of getting a test statistic of 127.859 or above if the null is true is 0.001. So this probability is very low. And the distribution of the statistic is like this. And the probability of less than 0.001 lies here in this area. So our this is our test statistic, our chi-square test statistic of 127.859 lies here, and the values above this are by this probability 0.001. How can we interpret this? If p is less than 0.05, we reject the null. So since this p value is less than 0.05, so we reject the null hypothesis and we conclude that there is association between class and survival. But what is the nature of this association or relationships? Were wealthy people more likely to survive on board the Titanic? Option 1. Choose the right percentages from the next slide to investigate. Fill in the stacked bar chart with the chosen percentages. Write a summary to go with the chart. Now here is the contingency tables. Which percentage are better for investigating whether class had an effect on survival? Now this is column, died, and this is a row, third row. Now 65.3% of those who died were in third class. 65.3% of those who died were in class third. 74% of those in third class died. So there is strong evidence that there is association between class and survival. So here is the stacked diagram, bar chart comparing death rates by class, and you have to fill in the percentages on the stack bar chart and then interpret. Now the green shows survived and the blue shows died. You have to write here the percentage and write here the percentage and here and so on. So did class affect survival? This is the solution. Percentages within each class are preferable due to different class frequencies. So you see these are the percentages. So using these figures we will put 35% here. This point will go to this, and this point will go to this, and this 74.5 will go to this. These are those who died. These are died in first class, these are those died in second class, and these are those died in third class. These are those survived in first class, those survived in second class, and survived in third class. Now data collected is on 1309 passengers aboard the Titanic was used to investigate whether class had an effect on chances of survival. There was evidence chi-squared is equal to 127.86 with p-value of less than 0.001 to suggest that there is strong association between class and survival. Figure 1 shows that class and chances of survival are related. As class decreases, the percentage of those surviving also decreases from 65% in first class to 26% in third class. This is a very good analysis. Low expected cell counts with the chi-squared, first class, second class, third class, number died, number survived. So chi-square test is this 127.859. So we have no cells with expected counts below 5, so that is good. And here A shows that 0 cells of 0.0% have expected count less than 5%. So it means that there is no cell which has counts less than 5. Low cell counts with the chi-square test. Check number of cells with expected counts less than 5. SPSS reports the percent of cells with an expected count less than 1. If more than 20%, then the test statistic does not approximate a chi-square distribution very well. If any expected cell counts are less than 1, then cannot use the chi-square distribution. In either case, if we have 2 by 2 table, use Fisher's exact test. SPSS reports this for 2 by 2 tables. In larger tables, that is 3 by 2, etc., combine categories to make all counts larger, providing it's meaningful. Thank you very much for watching this video. Ladies and gentlemen, in this video I discussed hypothesis testing using chi-square test with the help of SPSS. I hope you could understand how can we use a null hypothesis and alternative hypothesis, and then interpreting our results and making conclusion whether we have to reject null hypothesis or we have to go for or we strongly reject null hypothesis. So in this video the hypothesis testing only was based on chi-square test, that is categorical data. In the coming video I will try to use some other tests for hypothesis testing, like comparison of means, independent sample t-test, and so on. I hope you like this video. If you do like this video, kindly share this with your friends, with your colleagues, with your students, and subscribe to the channel if you haven't yet subscribed, and do not forget to click on bell icon so that you can get notification about other videos that I'm going to upload soon. Thank you, and have a good afternoon.